Hello everyone, my name is Aditya. Here we are going to design and implement a 2-digit digital stopwatch on the RealDigital Boolean Board. For this I am using Vivado software. Let's run a behavioral simulation to look at our waveforms, how they are working. Before that, only one change we will have to make it. The clock divisions here are right now around 100 million. The real FPGA board can easily go through 100 million clock cycles in 1 second, but here our computer's CPU has to mathematically calculate every single state of wire logic gates for every single one of those 100 million cycles just to simulate 1 second of stopwatch. So we will decrease this large value to some tiny value so that our 1 second tick will happen every 10 clock cycles instead of 100 million. Now let's run the simulation code. As we can see here, if we expand, our stopwatch is working very well. If we expand the 7 segment display, here we can see the value increase by the time, and the reset and stop buttons are also working properly. Also here we can see the LED outputs going from 0 to all the way up to 59. After this, let's run synthesis. After running this synthesis, it will translate our Verilog code into FPGA's language so that it can create basic logic gates and flip-flop blueprint. After running the synthesis, we will run implementation. This will just this will map our synthesized blueprint into the specific layout of our FPGA chip. Now the implementation has done. After everything is done, we will generate bitstream. This will pack all of our hardware configuration data into a single binary file. Then we transfer this file via USB to our FPGA board. The bitstream generation is completed. Now we can open hardware manager and program our device so that we can see the final output on our FPGA board. Let's move to the FPGA board and see how is our output looking.
Hello, I am Parth. We have designed and implemented a 2-digit digital stopwatch which counts from 0 to 59 seconds on the RealDigital Boolean Board. The stopwatch displays the output on both binary and decimal format through LEDs and LCD display respectively. For counting from 0 to 59, we require 6 bits. That's why we have used here 6 LEDs and 2 7-segment displays have been used here. Also, here we have used 2 buttons, that is J2 and J5, which corresponds to reset and start or stop button. So after pressing this, the counter stops, and after pressing it again, it will resume. Now it will continue counting up to 59 seconds, and it will roll over again to 0 and start counting again. Now after pressing this button for reset, the clock will get reset.